So thank you everyone for joining. This is the second webinar on the webinars for the road to the Expo 2020. I hope that our first speaker is logging in. If not, let me just continue with the opening. We have 90 minutes for our webinar. I'm very happy with the lineup which we have today. Let me start with giving a little bit of background. This webinar series of A Road to Expo 2020, also this second webinar where we will be talking about methods and applications. They're organized by the United Nations Committee of Experts on Big Data and Data Science for Official Statistics, together with the Statistical Office of the UAE, who have the regional hub for big data in the UAE. The Committee of Experts on Big Data, they started in 2014, and as a request from the statistical community to see what we could do on the use of big data and data science to improve the work of statistical offices. So how can statistical offices also make use of the changes in the digital society? Work was progressed through a number of task teams. We were working on, and we're still working on data, satellite data. What we will hear today is also scanner data and web scraping for price statistics. We also hear about today the use of mobile phone data for a variety of official statistics. We've been using the AIS, which is vessel tracking data, and we have some task teams that are looking at issues and challenges related to the use of big data, like how to preserve privacy. And so we will have the privacy preserving techniques team also presenting today. With that, we're working in this series of webinars towards the Expo 2020. It's a big event taking place in Dubai. Because of COVID, it has been postponed until 2021, but it started in October 2021 and will go on until March 2022. And within that context, there is a global goals week in the third week of January 2022. And as part of that, our community, together with our colleagues of UAE, will have a 3-day event explaining about the use of big data and data science for the community of official statistics. So we're really much looking forward to that. And this series of webinars introduces and shows what our community has done so far already. Before I move to our speakers, I would like to mention that if you have questions on any of the presentations, please use the chat to post your questions, and we will try to pick up some questions after each of the presentations. We have in our lineup today 4 different segments. We will start with machine learning as it is done in the UAE. I see that that Dr. Dimitri Ruta is on, so I'm very happy with that. Then we will have a presentation by Tanya Flower from the Office of National Statistics of the UK regarding use of scanner data and web scraping for price statistics. We then have a segment on the mobile phone data with colleagues Esperanza Macpante and Sim Esco from Presidium. And then we'll close with a segment on the use of privacy-preserving techniques done by Maciej Juk and Jack Fitzsimmons, and I will introduce everyone when we go to the presentation. So we will start with the presentation. Very happy to have here Dimitri Ruta. He is a chief scientist at the Emirates ICT Innovation Center at the Khalifa University, where he leads big data analytics and machine learning group. There is more information on the background of Dr. Ruta on the website. I do not want to take too much time, and I will move to Dr. Ruta, please, to have 15 minutes to tell us about sustainable, explainable, and actionable machine learning to deliver a positive change in the UAE. Dimitri Ruta, please, the floor is yours.
Thank you very much, Ronald, for a nice introduction. Just checking if everyone can hear me.
Yes, we hear you very loud and clear.
Perfect, thank you. Yes, good afternoon, good morning, depending on the location. Very proud to be able to talk to such a prestigious audience today. Let me just quickly share the slides. Should be visible now.
Yes, we see your slides. Yeah.
So is it in the presentation mode? Okay. Yeah. I'd like to, as Ronald mentioned, I lead big data and machine learning analytics at EPTIC Innovation Center, housed in Khalifa University. So we are more of a kind of industrial flavored innovation center, looking at all academic and applied research, machine learning in big data. So today I'd like to talk a little bit more about the new interesting aspects of machine learning, specifically sustainability, explainability, and actionability of machine learning. And that's effectively what's been happening in the wake of this enormous growth in kind of wave of big data penetrating every aspect of our life. And I want to share with you our kind of innovative approach of dealing with this type of problems, and also explain how we try to deliver value in this new situation across a number of use cases in the UAE. So let's first recap what is the situation in the machine learning. Predominantly, it can be defined as an enormous exponential growth of data, and that is obviously accelerated by all this new developments in mobile, social, cloud, IoT technologies interacting with each other. At the moment, we are at the rate of sort of 2 megabytes per person per second. That's how much data is being constantly generated. Important aspect of this, perhaps more interesting, is that 90% of the data ever generated by human has been created in the last 2 years. What it means is that literally in the kind of data world is almost renewing itself every 2 years. Every data world that we knew is corresponding now to the kind of 10% of data from the last 2 years. So it's really almost like a living through the revolution on the data front. So this is just the beginning. I mean, if we think about what could be in store in terms of macro and micro scale penetration, if we get down to the cellular level of sensors revolutionizing biotechnology pretty soon, or at the macro scale of climate, political, economical systems, the global systems, basically simulations, etc. There's much more to come.
Dimitri, and sorry to interrupt. I'm not sure if you try to move your slides, but we only see the front slide from your presentation.
Okay, that's strange. I'm in this. Can you not see? Let me share again.
Yeah, please share again and then move it to the slide presentation.
Okay, I'll share my screen just to be on the safe side. On see my screen now? The second slide?
Yes, I think so. Yeah, this says
Okay.
unprecedented rise in ML. Yes.
Yes, apologies for that. So as I mentioned, we are seeing the spectacular successes of deep learning. And that is, however, predominantly limited to the computer vision and some elements of time series or temporal forecasting, at least. However, we still don't see the kind of accumulative reusability of machine learning developments models. We see to a certain extent the transfer learning, but again, it's limited to certain narrow domains. And in principle, machine learning projects often end up being a one-offs that is not followed up as soon as the developer moves on to different projects, etc. So this is the area to look into to rapidly accelerate developments in machine learning. In terms of challenges that we would like to see solved, still a lack of full automation of machine learning pipeline. Obviously, scalability is always an issue, and we consider linear scalability is required to, or at most linear, to really address the problems that if we want to address twice more workload, we need to twice more resources rather than at some point beyond linear. Sooner or later, the problems become intractable. Explainability of machine learning is always an issue. And as soon as we don't understand what machine learning model is doing, we treat it as a black box. As soon as it runs into problems, there is no way to move forward with that. As well as certain interesting aspects of kind of typical development pipeline for machine learning models, which I want to now quickly go through. What we typically do with machine learning is really looking at the data and trying to infer from the data through the algorithm what is likely data representing. We build a model of the data in order to deliver some kind of predictions. That's been typical story so far. Now we try to adapt, obviously, to improve the predictions based on the data. We try to improve what algorithm, the model. Now what increasingly is happening is that the predictions are being triggering the actions. So the prediction is leading to actions which are trying to achieve certain valuable, successful outcome. And again, a result of the action could be refined, feedback to improve the whole pipeline. And the ultimate, what I would say, the true nature of artificial intelligence is where the actions are actually directed in such a way that they deliver self-improvement of some kind of benefit function that we measure. So there's a robot here of Boston Dynamics creation. The success function could be just the amount of time staying upright or ability to successfully pass different objects to and from, etc. So there's a lot of different functions of benefit that you can design for artificial intelligence. Obviously, that's a interesting aspect for ethics and for philosophy to investigate in the future. But that's the true nature of AI that we are almost on the verge of exploring, the ability of self-improving of the machine learning setup to basically have no touch from human and continue to improve itself. Another important aspect before I move into the kind of interesting elements of what we have done is the sustainability of machine learning. I have to say, struck by the kind of realization that machine learning right now is a serious concern for the sustainability and the CO2 footprint, energy consumption of training a simple machine learning model is really an issue. Um, so I believe the reason for that is that the machine learning becomes partly automated, and also we are following into this trap of lazy machine learning, where we don't see really where the things are processed. They have a cloud compute infrastructure. So we don't understand the data. So there is this lazy tendency of let's try all the data coming from source A to against the problem B, see if it works or not, move on to that. So penetrate and go through all kind of data that we can gather to test if we can get any improvement. So this is leading to enormous kind of issue for in terms of the consumption, power consumption for the training of machine learning. And deep learning, for example, is a major contributor to that. Obviously, GPUs are an excellent development story, a success story, but obviously they are very hungry for power. And there is a need for some kind of sensible, sustainable approach to machine learning in order to sustainably and responsibly move forward with it, rather than what seems to be happening now. And we believe that response, the kind of characteristics of sustainable and scalable machine learning should be at most linear scalability of the algorithm with respect to the data, efficient usage of parallel processing. The more parallelizable everything we do is, the less power per computing unit is basically used. So then also there is so much data, and all the data present all different challenges for different problems, but we would like to always compress the data down to the bare minimum that is sufficient to model and represent the problem in terms of prediction, exposing its predictive power against the objective of the prediction or the machine learning problem. We also encourage to not move data if it's not needed. So ideally, if the data can stay at the source, especially in the UE, very important not to transfer data around and data to stay within the UE borders, as well as all this sort of security aspects of data. Sometimes also create unnecessary copies of data that are flying around without any kind of responsible care in terms of sustainability. So now I'll go through a couple of use cases and maybe describe a little bit of our pipeline that we propose to address all these challenges. And I think we have some early successes of dealing and solving a couple of problems relatively efficiently with respect to this sustainability, explainability, and actionability of machine learning. So what is our pipeline? Effectively, the key principle of is the kind of paradigm shift in machine learning that we try to promote, in which we transform every single data column into a potential or a potential predictor, singleton predictor. So we turn every data column as a single independent predictor of the target. And the target, which is the objective of machine learning, target could be is there likely to be a fault on the TV line here, or is the customer gonna terminate the contract with us tomorrow or not? Things like that. It's always a binary yes/no question. As soon as you know what is it that you try to model or predict, then only you start invoking some action from the data and machine learning front. Otherwise, there is nothing needed. So the very beginning of the story is identify your binary target for prediction or modeling. As soon as this is done, everything else could be potentially fully automated. And this automation would traverse through all different data columns that are linked to the target that you're trying to predict. And as I mentioned, we try to convert every single data column into a single, ideally binary, or at least a risk-based predictor of the target independently. Why independently? Because if it's independent processing, then we can extremely easy mass parallelize the whole process. And we can very quickly determine whether this individual column is of any use for the target or not. If not, we don't really follow through with it. And that way we straight away kind of clean the predictive structure of every data column that there is, and only work with what's relevant for our data problem. As you can see here, there's a little table that represents an example data. And look what typically happens. What is our first stage in this pipeline is ordinal encoding. What I mean is that you see this data, sometimes there are dates, there are the text aspects, different numerical data, of course, but we can easily look at all unique values within them and convert them to the simple reference to the unique element of the dictionary that we created. And that way, instead of very occupant data types, we would be dealing with only ordinal numbers, sometimes even binary represented numbers. And that way we can compress it something like 100 times data right out of the start, or it can equally push 100 times more data into the memory that we are trying to work with on the data problem. And it's much easier and much cleaner to work with such data. And similarly, all the missing data problem is automatically encoded. We simply assign the value of 0 to it. Numerical categorical data, all is covered in the single ordinal encoding framework at the start.
Dimitri, sorry to interrupt. 2 more minutes, please.
Okay. Okay, so I have to accelerate. So that's an essential principle. Once we do the encoding, we are then trying to wrap all the predictive power of every column into either binary or multi-node bins. And this wrapping is simply done by uh, uh, looking into the domain and checking whether the specific areas of the domain increase or decrease the target rate within them. So effectively, every individual column is turned into either binary or ordinal numbers that we simply add up with a simple voting. So machine learning model becomes simple voting, but the feature engineering and cleaning of the predictive structure is the essence here. Now, what we achieved in the context of telecom is a spectacular success in terms of transparent, improved predictability of faults or predictability of churn prediction for the customer base. These data are after the step are also extremely easy visualizable. As you can see here, you can build easily heat maps, which you can cluster to discover groups of customers involving same features that represent some issues for our problem, and address straight away, much more efficiently addressing and designing the preventive structure. Maybe I cover one or two at most projects that are built on the same principle. Another major principle that we try to encourage is to reuse cross-correlation of geographical data layers through time and space with the objective data that you try to model. Here, for example, you have a problem of incidence or crime prediction. And as soon as you cross-correlate that with all different layers of information on the ground, there could be functions of the building, proximity to points of interest, you can readily extract useful factors to understand what encourages perhaps crime incidents in specific areas, as well as if you, for example, cross-correlate patrolling information on top of this data, you can design and improve much more preventive patrolling route for the police forces to multiply their preventive power through the presence. We have computationally, discovered that police presence is worth roughly 4 minutes of police time in a location is worth 1 crime less. If you, however, design and improve the route, which is the action that we discover through these predictions, you can multiply this effect and effectively 5 times increase the efficiency of preventive power of police presence in the area. Same happens with across other projects that we investigate. In another last perhaps project that I want to cover is also related to the police, and that is this time it's a traffic incident predictions. So the challenge here, which I presented at GITEX last year, was: is it possible to predict live the traffic accident risk as you go. As again, same approach, very collection of all possible data, including open data, traffic data from Dubai Open Data Portal, learning from history of the traffic itself, cross-correlated with various geographical layers, with live population density and live traffic data. And as a result, we have developed a system which we can basically, in real time, observe the risk of accidents in the next 15 minutes. And that could be, taken into account when you look at the security aspects or maybe choosing different paths with respect to dangerous issues along the route, etc. So many different interesting aspects of predictions like that. Maybe final one, if I have maybe 15 seconds, we are still living through the pandemic, so we are obviously active in that space, trying to model and predict various spread and design responses to the pandemic spread. This is what you see here is an example of the simulated model of whole population of UAE, 10 million roughly, following the different patterns of mobility, and through our innovative hierarchical presence transmission model that we have developed, we have been trying to assist local government entities to explore different patterns of transmissions that could happen, and assist and help to design responses to this pandemic. And I think that has been very successfully adopted in certain elements of the response strategy of the UAE. Thank you very much.
Thank you. Thank you very much, Dimitri. This is an excellent presentation. Also really like that you start out with some of the concerns that might be with the large increase in machine learning and AI, and then give some very interesting projects that you have been working on, which actually relates well with some of the work that especially the mobile phone team has been doing. I didn't see any specific question in the chat. I encourage everyone to if they have questions, to pose it there. Also, in the interest of time, we will move to the next presentation, but I would like to say, Dimitri, that all of what you were saying here is really interesting for our community of official statistics. We really will also follow up with that outside of this this setting to discuss and with you further about how there could be possible collaborations on this. We will have hopefully a little bit of Q&A at the end, and we'll try to see if we can tie in also questions for you. I hope you can stay on until then. Thank you very much.
Thank you very much. Very happy to follow up.
Yes.
Thank you.
I will move to the next presentation. It will be by Tanya Flower. She is the chair of the UN task team on scanner data since the beginning of 2020, and she works at the Office for National Statistics in the UK, where she's heading the team on innovating and it's a transformation program for use of scanner data and web scraping for consumer price statistics. So with that, Tanya, I'll give the floor to you.
Sorry, I just shared my screen and I forgot to include the audio option, so I'll just reshare my screen again.
Please go ahead.
There we go. Hopefully this will work. Fab. Okay, hopefully that comes through. Can you see my slides okay?
Yes.
Brilliant. All right, thank you very much, and thank you for having me here today. As Ronald says, my name is Tanya Flower. I'm here as chair of the UN task team on scanner data to talk you through our work and specifically the new methods that are required to use these data. So firstly, just quickly on the aim of the task team, our goal is to increase the use of new data sources, so web scraped and scanner data in consumer price statistics. I'll come on to define those data sources in a bit more detail later. So as with the other task teams, our aim is to produce guidance and training on the use of these new data sources and the associated methods, as well as promoting the use of tested code that can be used for research and development. So what are we trying to change here? So traditional measures of consumer prices are based on measuring the price change of a fixed set of consumer goods and services over a given time period, usually a year. So national stats offices generally collect the prices of a sample of these goods and services in the field every period, for example, each month or quarter. Price index methods are then used to calculate low-level price indices. These are then aggregated using expenditure weights into higher level indices until we get a single headline rate of inflation. The increasing availability of new data sources allows us to introduce new methods that better reflect price change in the economy. So what are these new data sources? So we have transaction data, which includes scanner data. These are data that reflect actual purchases by consumers. So observations may represent individual transactions or aggregations of sales at a product level. The data can be used to derive transaction prices using quantity and expenditure information. On the other hand, we've got web scrape data, which are data collected via a process of automated data collection where computer programs extract relevant data elements, such as list price and product details, from websites. So this slide summarizes some of the features of these data sources compared to the traditional collection of data. For example, you can see that data acquisition can be automated for these new data sources. And in terms of coverage, they are much more representative than traditional collection, which generally captures a single point in time within the collection period. Scanner data also have expenditure information available to ensure more accurate weighting at the product level. Of course, there are also challenges to these new data. The size of these new data mean that new methods are required to process them, which in turn likely means new processing systems are required to be built. These data are never going to fully replace the traditional collection, so we also need methods for integrating these data sources alongside these current collections. Finally, to implement these methods or collection methods, specifically web scraping in this sense, you also need to be able to train and upskill your existing staff. So in particular, I wanted to give you a bit more of a flavour for the methods required to process these new data sources. For example, even the preparation of the data requires innovative solutions. In the traditional data, collectors can manually identify if a product has been relaunched. So, for example, it's been given some new packaging. It is essentially the same product though, so any price change associated with the rebranding should be captured. In the new data, it is likely that this product is giving a new product ID, so we need some way of automatically linking this product to ensure that we don't miss any price changes. And this requires the use of data matching techniques and so on. We also need to classify the data to our product hierarchy. Depending on the situation, this can range from simple keyword filters to more sophisticated supervised machine learning models. We also need to automatically detect outliers, again ranging from simple filters to more complex unsupervised machine learning, such as clustering. A lot of focus has been spent developing new price index methods that use more of the data than the traditional index methods. And then finally, we also need methods, as I said previously, to aggregate the data alongside the current collection. So many of these methods are still subject to ongoing research, while some are already being used for production processes in national stats offices across the world. There is a huge opportunity here to share experience and learn from others who have already implemented these data and methods in production and how they have overcome these challenges. Our main goal as a task team is to enable these conversations. We're aiming to do this in 3 parts. So the production of an e-handbook for using these data in consumer price statistics, including discussion on what methods are suitable. Promoting the use of tested methods and code to reduce the development burden. So the longer term goal here is to add a code library for consumer prices using these data into the UN global platform that Ronald mentioned earlier. Finally, we're aiming to produce training material that can be used by the regional hubs to promote the use of these data sources globally. So on the next slide is a demo that I recorded a couple of weeks ago that showcases the e-handbook that we've been developing. So I'm going to play it. Please shout if you can't hear the audio, and I might have to reshare my screen again, but I'll pause it after a couple of seconds. Hi, my name is Tanya Flower and I'm the Workstream 1 lead. Can everyone hear the sound okay?
Yes, it's fine.
Thumbs up.
It's good.
Okay, excellent. Thank you. I will play the video now. Hi, my name is Tanya Flower and I'm the Workstream 1 lead. Today I'm going to give you a quick overview of the Prices e-handbook that we have been developing. The aim of the wiki is to provide an online publicly available guide for anyone interested in using new data sources like scanner and web scrape data to produce consumer price statistics. It will be a living document, so the pages will be reviewed periodically over time to ensure that it remains up to date and new research findings are reflected in its contents. Here I've got an overview of its structure. You can see how we've gone from the very beginning stages of data acquisition to how to process these data and then integrate them alongside existing data sources. The idea is not to provide a single recommendation on the best approach, but to summarize best practice and research findings in order to allow organizations to be able to make decisions that suit their own particular situations. So I'll just go on to a page that's in a bit more developed, so you can see the level of detail that we have. So each page will summarize the topic, and then there will be links provided for users looking for further information. For example, the ILO CPI manual has a lot of very useful technical information that we could reference for further detail. Once published, all users will be able to provide comments and feedback on each page so that the content remains up to date and useful. As I said, it's still in development at the moment, but we're hoping to have a version ready for wider review towards the end of this year. Big thanks to everyone in Workstream 1 who's worked on this so far, and we look forward to being able to share it more widely, as we believe it will be a very helpful resource for the international community. If you have any feedback or you would like to get involved further, Thomas is sharing our contact details at the end of this presentation. Thank you. Fab, okay. So as I mentioned as well, the longer term solution is to get a library of code available on the UN global platform. In the meantime, there are a couple of packages already available in R that can be used to process these data to produce consumer price statistics. My colleague Asek Bialek has recorded a demonstration of the code package he has developed that can be used to produce consumer price statistics using these new methods. As you can see, the package also comes preloaded with some test data that can be used for research and development purposes.
Good morning, good evening, hello everyone. My name is Jacek Białek and I'm going to show you how to move from raw scanner datasets to price index values in the price indices package. Here we have goals of the package. As one can see, the package may serve as a tool for data processing just before price index calculations and for calculations of bilateral and multilateral price indices. The current version of the package, version 0.05, consists of almost 160 functions, but to be honest, about 40 new functions are still under construction. They will be available in the upcoming version of the package, 0.06. The whole documentation of the package can be found in that location. You can easily install the package from the GitHub or from the CRAN. This is the sample typical data frame obtained from one of Polish retail chains. So as a rule, the Statistics Poland obtains scanner datasets in the CSV format, like in this case, with original Polish names of columns. To be honest, if you want to cooperate with the package, you should prepare your datasets carefully. One way to reach this aim is to run data preparing function. In that function, you have to select the right columns names in the information on prices, quantities, product label, product codes, and retailer codes. After that, you get the data frame which is free from missing values, and all weird prices like negative prices or zero prices, zero quantities are excluded from the sample. The next step, one of the initial steps, is to product classification. In the package, you have two options to reach this. The first one concerning data selecting function, which is based on the simple text mining methods. In that case, you have to use parameters like include, exclude, or must. For instance, the must parameter indicates the set of keywords that must appear in the product description. The second option is to use machine learning techniques, for instance, by using the model classification function. So that function is based on the XGBoost algorithm from the random trees methodology. The only thing you have to do is to select the training dataset, the testing dataset, the grid of models parameters, like the speed of learning, the set of indicators, and eventually the set of keywords. You can easily save the model on the disk, and you can load it anytime you need it. Sometimes there is a need to extract the information about the grammage or product description from the product label. In this case, you can run the data unit function. So after using that function, you will get two additional columns, I mean the grammage and the unit. The next potential step is data standardization. If you want to transform prices and quantities to obtain new ones which concern the whole product unit, then you can run a data norm function with the set of rules selected in that parameter. Finally, you should match product over time, for instance by using data matching function. If your data frame is complete, I mean you have all codes, product codes, and also product description, then these parameters should be set to true, and as a result you will obtain the same data frame with one more column prod ID. It works in that sense that two products are matched if they have identical prod IDs. Next, you can consider data filtering. In the package you have all three typical data filtering methods implemented. I mean you have the low sales filter, the extreme price filter, and the dump price filter too. Finally, you can calculate index methods like bilateral ones. In this case we have the Jevons price index and the Fisher one calculated. If you want to have the chain index, for instance the chain Turnquist one, you have to add C and H just before the name of the index. You can calculate also multilateral price index methods, like in this case where the GEX index, the CCDI, the Garikamis, the time product dummy are calculated for the dataset on coffee products. Of course, the SPQ price index, which is quite new and fresh in the literature, is also available in the package. You can extend your results by using splicing methods and by using the fixed base expanding window method here, or the fixed base moving window method, which is not presented on the slide. You can aggregate your results over product subgroups or over outlets. To reach this aim, you can run the final index to function. After that, you will get the results for the whole group of products here, and also for each group separately here. Here we have, of course, Polish names, but they denote ground coffee, coffee beans, and so on. If the figure parameter is set to true, then the results appear in the figure. You can also compare price indices calculated in the same dataset by using the compare indices function. And this is the sample figure. And finally, in the upcoming version of the package, the compare distances function will be also available. As a result, it provides the special matrix with mean absolute distances between the compared price indices. So this is the second option for any price index comparisons. And here we have some suggestions for future plans for the package. I would like to add the composition methods, the Mars method for data stratification, and also some new price indices, including my own ideas, to the package. Thank you very much for your attention. If you have any questions, please feel free to contact me and write to me. Thank you very much once again, and goodbye.
Okay. So as I said, that isn't on the UN Global Platform at the moment, but it has been tested by a few experts within our task team, and the methods are valid in the package. So that's available for research and development from now. Just to note as well, the final session in this Road to Expo webinar series is presented by the training task team. So there is a section on that, on our scanner data training in that session. So I won't touch on it further here, but if you're interested, please go along to that. And I'll leave you with this last slide with our contact details. So I mentioned in the video we have different work streams. So I'm the chair in work stream 1 lead. We're leading on developing the wiki. Ingolf is in charge of the classification work stream as a particularly big area of new methods development. And Thomas is in charge of the training work stream. So he'll be the one presenting in the next session. And then Jacek's contact details are also there as well. So happy to take any questions.
Thank you. Thank you very much, Tanya. And I thought it was really clear and in all detail to understand how this transformation towards scanner and web scraping actually works. So thank you for that. I do not see any particular question in the chat. One maybe short brief question on this is how this works, the integration of the new methods into the production of a statistical office. So maybe you can speak for yourself on how this works in the UK if you're moving gradually to include scanner data and web scraping. Please go ahead.
Yeah, so as I said, that's my day-to-day business role, is to work in the ONS to develop our transformation of consumer price statistics. So we've gone through quite a period of research to get to the place where we are now. As I said, although the wiki will be there to provide kind of a summary of best practice and recommendations, each country will need to have some kind of process to go through to actually implement those methods in their own specific scenarios. In terms of implementation strategy, we found that focusing on specific areas is quite useful. So scanner data for groceries is generally more accessible than some other areas. So, and there's a lot of literature available about the groceries section and using these new data sources for it. So we focused on groceries, and then we're kind of having a rolling program of continuous improvement and extending it to other areas of the basket as we go. Thank you
very much. I see one hand up. We are conscious of time. So this is from Gina. Maybe Gina, could you add your question in the chat, and then we'll maybe be able to pick it up a little bit later. Thank you. Okay, I will move. Thank you very much, Tanya. That was great. We'll move to the next segment, which is on the use of mobile phone data for official statistics. We have here Ms. Esperanza Macpante from the International Telecommunications Union. Esperanza is their senior statisticians for ICT data or in the ICT data and analytics division, and she's responsible for collection, harmonization, and dissemination of ICT statistics. We also have Sim Esco. Sim is working in the private sector. He is head of sales and marketing at Positium. Has been working with large public sector institutions across the globe. Has been working also with our community over the last several years. So with that, I give it to Esperanza and Tim to tell us about how we can use mobile phone data for official statistics. Esperanza, please go ahead.
Thank you very much. Can you see my screen now?
I can see yes. Now we see your slides. Thank you.
Thank you very much. Good afternoon, good morning, good evening, everyone. So I'm going to present to you the work of the mobile phone data task team, particularly giving an overview of the achievements and the future plans that we have that lines up the work that could be useful for the work of the regional hubs. So I will be focusing on 4 different areas, mainly to describe the activities, the achievements, and the products that we produce within the task team. So just to give you an overview, the mobile phone task team is currently composed of more than 50 individual members representing international, regional, and as well as countries, think tanks, and private institutions. So the objective of the task team is to indeed develop methodologies to get complementary information that could be used to check quality and produce indicators that relates, for example, to SDG and other areas of statistics, and using these methods to produce materials that could be used to deliver capacity building workshops, awareness raising, and implement projects that could be replicated in countries and testing the mobile phone data. The task team meets virtually regularly every month to discuss all the deliverables and products, as well as events that we are responsible in terms of the organization and participation. So you'll see in the screen the different agencies and countries that works within the MPD task team. So the handbook on the mobile phone data is one of the main achievements of the task team. This task team started a while back, and in 2019, the first handbook on the use of mobile phone data was released. And this handbook specifically highlights the different applications or the different areas of statistics where mobile phone data could be used, where the different methods, concepts, how the data could be processed, and checking the quality of the data derived from mobile phone could be performed, as well as emphasizing on the data access methods and partnerships that could be used when accessing the mobile phone data. But more recently, the task team has engaged in preparing different handbooks, which will be hope to elaborate the previous handbook, which will focus on 6 areas of statistics. And the objective is to be able to really provide more detailed information with regards to the applications as well as methods that were already described in the first handbook. So these 6 handbooks are more specific and more detailed in terms of the methods and the concepts that were used in the implementation of the different projects and pilots. So the 6 handbooks that we have, you can see we have tourism statistics. This is actually led by the BPS Indonesia. We have migration statistics, which is currently being led by Geostat of Georgia. We have census and dynamic population, which is led by Positium. We have transport and commuting statistics, currently being led by the World Bank. The information society indicators, which is currently being led by ITU, as well as the displacement in disaster context, which is currently being led by the University of Tokyo. So the idea is within these different areas of statistics, different groups of people through a subgroups are working on preparing handbooks that could be used later on to produce the training materials that will be delivered in workshops as well as in regional hubs. So as an example, and this is the handbook that is currently being finalized that focuses on the use of mobile phone data for information society indicators, particularly focusing on the 2 SDG indicators that are included in the monitoring framework. And the idea is using these 2 indicators and the mobile phone data, we wanted to provide an introduction on how and context in terms of the use of mobile phone data, as well as how to access the data and what sorts of preparations that needs to be done in countries in order to make use of this data. There's also information on the reference materials or reference data that could be used in collaboration with the mobile phone data. So in addition to mobile phone data, we need to know the world population data, what are the local admin units, for example, and household survey data to serve as our ground truth data. There's also data processing information that provides information in terms of the data processing models and data protection guidelines that could be used by countries. And finally, there's methods that relates to how the two indicators could be calculated, providing the rationale on why we need to calculate the indicators, the definition that relates to the indicators, as well as the quality assurance information to check on the data that will be used to calculate those indicators. There's a separate section on quality assurance, which is basically comparing the data that were derived from mobile phone as against the household survey data, whether the results make sense. And finally, there are country experiences that highlights how mobile phone big data could be used to derive these two indicators on the SDGs. So the other activities and other achievements of the mobile phone task team includes several events that we organized since 2017. There were a number of workshops that were done in Colombia, Rwanda, as well as in Georgia. In 2020, there were global events that happened in Korea, hosted by Korea in the Big Data Conference, as well as in the World Telecom Indicator Symposium of the ITU. There's also the Mobile Tier 2 Week, where the mobile phone data task team's work was presented. And finally, in 2021, there were a number of events where the mobile phone task team presented its work. One of them is the ISI. There was also the WSIS Forum in May, as well as the MPD presentation during the SCAP Stats Cafe and a webinar where the Oman's experience was presented. One of another important achievement of the task team was the publication of a paper that was published in the Data and Policy Journal in the beginning of October, where it highlights the principles in maintaining public trust in the use of mobile phone data for policy purposes. So this is specifically applied when using mobile phone data in the context of the COVID pandemic. And we presented this paper in the World Data Forum in the beginning of October, and then it has attracted a number of attention, both in the forum itself and in the Data and Policy Journal. And of course, this webinar that we are presenting today. So in terms of the future plans, of course, the main focus now of the task team is to publish the 6 handbooks. And we hope to achieve that in the beginning of 2022. And based on these handbooks, we want to prepare training materials that could be used to conduct training workshops in collaboration with the regional hubs. The first one specifically is on awareness raising that is currently being prepared by one of the subgroups of the task team, as well as to produce a promotional video highlighting the achievements and the work of the mobile phone task team. And finally, we want to also organize a session during the EXPO 2020 in January 2022.
Thank you, Esperanza. We move to Sim, please.
Hi, Ronald, and thank you all for joining us. So Ronald, just tell me when to stop. There's a lot to go through. I'll start with the idea why mobile phone data is important. Well, the world is more dynamic. We've seen it time and time again, and people are in different places at each time. So when the world seems to be on the move, so what do the decision makers want? They want more data, they want it in greater detail, they need it fast. And then the pandemic hit, and decision makers want data even faster and even more in greater detail. So what do we do when this comes up? If only we had a sensor to measure human mobility. And we do. Most people in the world now have access to a mobile phone. People can leave home without a watch, a credit card, or even laptop, but they will not forget their phone. So when you think of a mobile phone as a sensor, then how does the data from these sensors look? So this is one day of mobile data from one mobile network operator in Estonia, and this is how it looks. 18 million location events for a pretty small country, and even one day of data is well correlated to the population map. And this is also the first thing that you do when you get access to data, right? You check the representativeness of this data source. Then you check the logic of the data source. So how does this data look when we look into the data? And we should also see a logical distribution of records coming in from mobile phones. And for example, this is what we see when we look at data from one operator in Oman in the Middle East. So x-axis is the hour of the day, and y-axis is thousands of events that take place within a certain hour. And it follows the natural rhythm of people as they use their mobile phones throughout the day, early morning hours being most active, and then it goes down as the evening progresses. So we've seen time and time again that this data is reliable and usable. And the question is, how does this relate to statistics? And of course, the point for statistics is to provide a reliable base of truth for decision makers and see how changes in data require maybe new decisions. So I'll give you examples from the field of statistics and how they apply for planning. And the fields that we've discovered where MPD is already having an impact on statistics are these 6. As Brans already presented, there are handbooks for all of these. I will just present some examples to give you an idea, and hopefully this urges you to explore further and together with us. So what is the most natural statistical area to measure with mobile phone data? Of course, it is mobile phone use. The work done by the ITU has increased the reliability of this data for SDG indicator calculation, for example, for mobile coverage and use for internet access. So tests in Indonesia and Brazil show that the results are comparable and even better than household survey results in some regards in those countries. So better in terms of disaggregation and how it provides the statistical producer independence in compiling the data. And the independence is one of the fundamental principles of visual statistics. And for example, this year, 2021 was the first year where Indonesia could provide disaggregated data on indicator 9C1 to the UN Voluntary National Review on SDGs. And I already presented how one day of data looks. If you produce population data out of this, it can be used for monthly population or for daily population. And daily population being one of those hard to reach areas of statistics, daytime population, nighttime population, that we are trying to measure with the census, for example, every 10 years. And MPD has many different uses in population statistics. I should point out that population data from mobile phone data is actually the basis for most of the statistics that I will introduce as examples from now on. For example, transportation statistics. So how the population moves between home and work and how they do other trips is, if you put that into origin destination matrices, it becomes the basis, for example, on how to build an efficient demand-based public transportation network. So, for example, the city of Tartu in Estonia devised a new bus network and put it running in just 2 years. Even for a small city, for 100,000 people living in a city, you could generate 6 million movements. And this was combined with other data, for example, registry data, interviews, surveys, and land use data to provide for understanding how to model new, more efficient routes. So the result here was 13 routes instead of 27 and increased bus ridership. So it really does have an effect. Disaster management. As the pandemic hit, many countries and governments, they found out that there's not many data sets where we can understand how population mobility changes. But during this time, we had to change the mobility patterns of people. So very fast, what happened was that 40 countries in the world started to operate mobile phone data for policymaking insights. And for example, the European Commission took data from 16 European Union countries to map out new mobility functional areas, how they changed, and also understand how policies on restriction on mobility were having an effect on how people actually changed their mobility patterns. But tourism statistics remains the most important case here, because as the pandemic went on, the central banks of Estonia and Statistical Office of Indonesia continued to produce tourism statistics through the same data source, through mobile positioning data. And you can see they have done this since 2009. So for tourism statistics, we have the most long-standing use cases for over 13 years now and running, because the data set goes back to 2008 and with great results. And this is why this production still happens, is because the data produced for tourism in Estonia is now faster, sample size is higher, and it's actually more cost efficient for the statistical producer. Now, what this means is success comes with the right data pipeline setup. So one of the key things that we always say is to include necessary stakeholders, for example, the telecom regulator and data protection authority, and to cooperate with experienced solution providers and find a way to cooperate with the data provider. But most of all, follow the best practices. And this is why we have set up these handbooks and the UN Committee of Experts on Big Data. So I urge you to follow the work of and join this committee of experts to find out more on where and how to use MPD.
Thank you very much, Sim. And yes, I mean, for all those working in the statistical community, but also further than that, if you want to work with us, we are really a community of practice in various areas, and including this area of use of mobile phone data. I pick up one question, if you can get a short reply to that from the chat, and I formulated a bit more general, is that yes, Sim, you mentioned that under specific circumstances, the EU was able to get access to all kinds of mobile phone data. But maybe more generally, how difficult is it to get access to mobile phone data to use them for policy purposes? Both to you and Esperanza wants to pick it up, but Sim, yeah, go ahead.
Yes, Esperanza might have a thing to say here, because she literally wrote the chapter on mobile phone data access for the first handbook. But it is it is difficult. I mean, any big data source, getting your hands on it is difficult. But we can see from the experience of COVID, that when there is a need, where there's a certain use case that is needed to be solved, so it's not just the personal interest of somebody, but there is actually there is a need for this data to happen, then this data to be collected, then it can be accessed. So with the right set of stakeholders, and if you set up the data pipeline correctly.
Esperanza.
Yes, I just want to add to what Sim mentioned, and exactly the role of the different stakeholders and working together within the country is very important. From our use cases, the experiences really varies. There are countries where it's really easy to get the data, but countries where they don't want, the operators doesn't want to share the data. And so here it's the stakeholders' role is very important. And as Sim mentioned, it's best to talk from the beginning and involve even the data protection agency to make sure that the data will be used for statistical purposes. Thank you.
Thank you for the concise answer. Yeah, so within the stakeholders, the data protection office is one of them, and we've noticed that they are very important. So it's the mobile phone operator, it's the data protection office, and then the statistical offices and service providers like Positium together, getting to agreements on the use of the data. Thank you very much, Esperanza and Sim. And we move to the last segment on privacy preserving techniques. So access to mobile phone data is one, but in general, access to any sensitive data is important and difficult. So we have Matthias. He's from Statistics Netherlands. He's the Chief Information Officer at Statistics Netherlands. And we also have Jack Fitzsimmons. He's a head of technology of Oblivious in Ireland, I think. I hope I have that correct. So I would like to give the floor to Matthias on he's leading the privacy preserving techniques group within this UN Committee of Experts, and he will be talking about enabling international collaboration via privacy enhancing technology, and Jack will then come in with some concrete demo. Please go ahead, Matthias.
Thank you, Ronald, and welcome everyone. Yeah, first, just a short correction. I'm head of CIO office at Statistics Netherlands. So Chief Information Officer is actually my boss, but that's all right. First, I will give you some overview of the work of this task team. And then later, Jack will present some actual techniques and also do a short demo. Dr. Ruta mentioned some fascinating facts about how much data is being generated by each individual these days, and it's extremely important to safeguard privacy of these individuals, but also companies and institutions, as statistical organization process, analyze, and publish all this data. So I have to confirm that this approach is already firmly anchored in statistical processes. However, we are facing new challenges. So societies need more insight into complex and often fast-moving issues such as COVID-19, and new, often very sensitive data sources are needed to answer this demand. So the mobile data presented earlier by Esperanza and Sim are perfect examples. And on the other side, there is also new regulation such as GDPR, and public is also more sensitive on their data privacy. This means we need to investigate and use more advanced techniques to address these new privacy risks. So this task team has experts from statistical organizations, academia, and private sector. And the purpose is to analyze new approaches for application statistical analysis, to identify use cases that are actually in statistical organizations, and then to investigate not only technical but also other capabilities such as organizational and legal. And to achieve this, we collaborate with other teams, and finally, we also disseminate our findings and learnings with the broader community. So the focus of this team is actually on methods to protect privacy of data while it's being processed or analyzed, which is called data news, rather than addressed or in transit. But of course, these are also important, but that's not our scope. So I'll go quickly through work streams. The most of insight is delivered via UN handbooks. So the first one was published in 2018. I just sharing the link to this handbook. And then when COVID crisis started in 2020, we started with exchange of experience of application of privacy preserving techniques in response activities such as contact tracing. So we had these exchanges for more than half a year. Then this year, we also started with training courses. So that is in partnership with open source community, openmind.org. And most recently, we started working on establishing safe environment to experiment with the PET technologies, as they are called, in UN global platform infrastructure. But Jack will show you a demo from that part. In terms of the UN handbooks, so next slide. This year, we are introducing some new additions to this handbook that I mentioned earlier. So the first thing is a description of statistical case studies. So we are collecting concrete case studies, and then we are also updating the methodologies and technologies chapter. So for example, I've been introducing synthetic data. We are also introducing in the handbook distributed learning. And we will also have first systematic inventory of all relevant international standards. A lot is still happening in this area, so there are a lot of standards in development, but it's quite fascinating how quickly things are evolving here. And last but not least, this year we have a task team that is investigating and writing report on legal guidelines for the use of privacy preserving techniques. All these reports will be delivered early next year. So quickly going through some examples. So for this, we reached out to UN-CEBD Input Privacy Project, which has quite a number of statistical organizations involved, and we have collected examples such as private set intersection from Italy and from US, the use of private text classification in cloud from Canada, most recently training of machine learning models on the use case of smartphone data collection, and then many or multiple uses of synthetic data, for example, to generate the training data for hackathons or to generate the data for public research. So in the description of these examples, we use main characteristics. So we describe main characteristics such as data sources, who are input, output, or computing parties, what is trust relationships, tech models, as well as list proposed solutions that are used in this project, and of course, most importantly, outcomes and lessons learned. Then we have a special task team that is developing legal guidelines. So this is led by my colleague Mayank Varia from Boston University. And the purpose of this team is to investigate and describe techniques compliance with legal obligations under privacy laws in different areas of the world. Now, audience here is lawyers, policymakers, but also data scientists, and the method is to develop a taxonomy which describes how to apply privacy preserving techniques consistent with the law. So that means we are investigating which are actors, what are the regulatory environments, how the privacy preserving technique deployments look like, but also considerations across the data life cycle, such as data minimization, privacy by design, and this report will also include specific examples that will show some concrete examples from statistical organizations. Next one is training. So this is led by Andrew Trask from University of Oxford. He is leader of openmind.org, open source community, which is developing the training courses. So these are free training courses. And the first one has already more than 7,000 learners registered, and second course will begin soon. So the link is also on the slide, but I can share it. So yeah, please register for these courses. Then last but very important is we want to really help building active privacy preserving techniques community of practice across statistical organizations. So we will be open for additional statistical use cases. So we are discussing also for possibility to have some sort of e-handbook or inventory of statistical use cases which we could update continuously. But we are also doing experimentation statistical use cases in safe environment. The way how this works is we are using no sensitive data, so we are using data that already has been published as a proxy or synthetic data, but we do have technical support for technologies from certain providers of these technologies. And of course, we are doing demo, and my colleague Jack will take over now and present this demo.
Hi, hopefully you can hear me. Thanks very much, Matthias. I hope the timing of changing slides was roughly okay. And yes,
no problem.
Ronald, you did get my where I'm based correct in Ireland. So listen, when we play with privacy enhancing technologies, really we're doing the art and science of, or the balancing act of balancing the security and privacy of sensitive data, along with how we can extract value from that data and use it for a particular purpose, right? And privacy enhancing technologies or privacy preserving technologies aren't going to solve this for you, but hopefully they can offer you a tool case which you can use to try to mitigate some of the risks and hopefully turn a no-go project into a go. When we typically talk about privacy enhancing technologies amongst the committee of experts, we typically talk about input privacy and output privacy. So input privacy is simply assuring that the data that you upload to a function or a server is used for a particular purpose and no extraneous purpose, no extra eyes can see that data. And output privacy is to make sure that the information disseminated from that function doesn't allow for reverse engineerability, essentially. So breaking these into, how do you actually achieve these? Well, for input privacy, typically there's kind of 3 buckets we think about. So there's find a trusted third party, or potentially your own infrastructure or something like that, where you just trust all of the parties involved, and so you're able to run your computation or your function that you want to perform or calculate. The second is to use secure enclaves. So these are typically hardware solutions or kind of hardware-software combinations that provide isolated environments and give guarantees about what's running inside of that trusted execution environment to one or more parties. And finally, there's pure encryption-based techniques, which don't have the hard requirements of the first 2, but tend to be very bandwidth and latency expensive, essentially. So it involves encrypting all of the data in a certain way so it can be manipulated without decrypting the data at any point. Output privacy is something that I think a lot of people in the statistics community will be quite familiar with. So often, especially at a census level, etc., aggregation and sensitivity analysis is performed. So before you're releasing information, perhaps about a population, you first want to make sure that the bins and buckets that you've aggregated over are safe enough that people can't reverse engineer and work out perhaps somebody's salary or jobs, etc. However, there's also quite a modern approach to this, referred to as differential privacy, which essentially involves adding noise or intentionally adding error to your data in such a way that reverse engineering the original data will become very, very tricky. So I think we have quite an interesting example for you that we've been working on with the committee as a bit of a showcase, which includes both of these arms of privacy enhancing technologies into a single use case application, essentially. We use Enclave Technology provided by AWS, Nitro Enclaves. In this case, the different cloud providers provide different options of exactly how they work, but we had to pick one, so we went with that. Along with the open source project, OpenDP and Smart Noise by Microsoft and Harvard for output privacy. And we essentially, what we do is we write code that all of the parties can read, understand, and agree that it's safe or fit for purpose. And we deploy it in this trusted execution environment to create an asset which can be shared as the output of this joint computation. So we are actually going to show you this in practice in real time. So hopefully the curse of demonstrations doesn't prevail this time. So the first thing we need to do is be able to connect to an enclave. So I'll tell you a little bit about this as we actually do it in real time. So we have data from 4 different countries, and we're going to upload this into the enclave of our choosing. First, we're going to request the attestation. So what this means is that we're going to connect to this enclave, and we're going to require the cloud provider in this case to send us back a document that is almost like a DocuSign, you can think of it. It says what is the program and environment that's running the software that we're expecting, and that the cloud provider digitally signs essentially hashes of the software and the environment variables that are involved. As this is sent back, embedded in there is also a public key. And so once that's sent back and I can confirm and validate that, yes, this is the program that we've all agreed to run, then I can use that public key to encrypt my data and send information back to the enclave. And so we can communicate through this encrypted channel that's been provided for us by, not by one of the parties involved, but actually by the underlying infrastructure itself. So what do we need to do? First, tell them where the enclave is. And secondly, tell the program what are the hashes, so what are the codes that basically define exactly what is running inside of this enclave. The reason these are fixed length is because no matter how large your program is, it will always be hashed down to a fixed length string like this. And finally, in this case, we've done this before, obviously, when people are uploading from different parties, but for the purpose of this demonstration, we're going to act as each of the parties, Canada, the US, Italy, and the Netherlands, perform this handshake, create a symmetric key from the enclave, and upload a CSV file, which you can actually find on the Comtrade data provided by the United Nations. So this will take a minute to basically get these keys, encrypt these very large CSV files, upload them, and once that all 4 countries have uploaded the data, then the program will run, which will basically create a report for us, which we can then download. So while that's running, let's pop back to the presentation and I'll tell you what's going on inside of the box. So we're generating a report in this case. And in the report, we might want to make sure that some of the statistics, especially the fine-grained statistics that may reveal information about an individual company in the context of international trade, or perhaps a user of a mobile device in some of the previous contexts that have been spoken about on this call. And we might want to share macro-level statistics about that while knowing reverse engineering isn't possible. We're using the OpenDP Differential Privacy Library and Smart Noise Framework to perform this. And essentially, as I said before, this will perturb all of our count statistics in this case, but it could also be averages, quantiles, standard deviations, etc., by an appropriate amount of noise to prevent reverse engineerability while also maintaining a lot of the value of the statistics provided. So in this case, for example, we can clearly see that the US believes they're exporting to Canada, very, very similar to what Canada believes it is importing from the US. That could be because they're actually using the goods that are imported and exported respectively, as opposed to doing forward trade as basically a shipping destination along the way. You'll see this in the report in a second once it's generated. The second interesting thing that we've added into this is actually that attestation document. It's that guarantee that's used to establish the channel of trust between the enclave to the clients who are uploading the data. We've actually used that same document and we've added it into a watermark, which is embedded into the PDF itself. And so when you scan and parse this PDF, you can extract out the public cert file of the certificate of authority, which generated this report inside of the enclave. And you can add it to, for example, your Adobe Acrobat reader or whichever PDF reader you prefer. And by doing so, you know not only the public keys of all of the parties that provided that data in the first place, the source code that generated the report during its creation, but also through this digital signature, you know that the report hasn't been changed from that initial creation right through until it's on the virtual desk, on the desktop of the decision maker who's maybe making an informed decision based on these statistics. And you can see all is done by the time I yapped away. We can download the report and response 200, that is good. You can see it was downloaded just a few seconds ago. And indeed, during that conversation, we've generated a report using data coming from 4 countries, which is a proxy for obviously sensitive data. Of course, a template was created beforehand, which can expand to far more data providers. We have, in this case, the US, Canada, the Netherlands, and Italy. And just for this framework, we put up every country in the world's flag there, so we can use it for different combos, for example, the EU or the ASEAN countries, etc. We have deterministic statistics if you want to do specific macro, high-level statistics that wouldn't be so sensitive to reveal. Or indeed, you can add differentially private statistics, which give you some of these insights which may be otherwise too sensitive to calculate. And indeed, we have the watermark embedded into the PDF. So to finish up, we leave you with one question. And this is, I imagine that everybody on this call in one point or another has worked with sensitive data that was blocked for one reason or another. The project was a no-go. And we're super interested to hear how we can use privacy enhancing technologies, perhaps, to overcome some of these challenges so that you can derive new value from otherwise too sensitive data. Perhaps Dimitri and Sim will show that competitors in the telecom space might be able to combine their data to give better, more informative statistics to national statistics offices, or indeed, Sanya might be able to onboard more companies who have scanner data at their registries without their fear of that data being used for extraneous purposes. So thank you very much, and we're happy to answer any questions also.
Thank you very much, Matthias and Jack, for a very, very well-rounded presentation. Just on to your last point, Jack, there was a question, and let me translate that or rephrase that in my words. Social media. So getting access to Twitter or Facebook or large loads of data. How do you, if we would be going into a conversation with them, what would we say about how privacy preserving techniques will help us keeping the original data secure, private, and as was said also here, that it would be ethically used, but it might be a different topic. But so to you, Matthias and Jack, who want to take this on first.
Well, I think you'd be in a good space to have that conversation. Actually, the large social networks are those who are some of the most fastest adopters of privacy technology. Very recently, VPs at Facebook were, talking down another very large tech company because they weren't putting as much time and effort into privacy enhancing technologies as their peers. And indeed, LinkedIn has already incorporated differential privacy into the information which they provide to marketing practitioners who want to advertise on their platform. So the fact that you'd be using technologies that are already established and used within those networks and companies is probably a point of trust in the first place. And you know, of course, it's always going to depend on terms of use, and there's a ton of legal and regulatory restrictions that might be involved. But at least from a buy-in perspective, these companies are actively now using privacy-enhancing technologies.
Matthias, you wanted to add on to that? Yeah.
Yeah, just in terms of the ethical aspect. So this is one of these additional, perspectives, like a legal, organizational, but also ethical. So of course that needs to be also looked in each project. So there are like ethical commissions, for example, in some projects where this is also looked from the perspective. Not only can we do it legally, but also should we do it? Is ethically, responsible to do it. So that's very important point.
Yeah, thank you for that. We're a little bit over time, but I will take one last question for you guys from Peter Sandberg, and he is asking how can the provider of the sensitive data get insight in the algorithm and how that was applied to the sensitive data, and if nothing was revealed in the final report. So how would that work?
Absolutely. So essentially what happened in the demonstration was we used an Enclave technology. So what that is that, again, it's a hardware software mix typically, or sometimes strictly hardware. And essentially you share what the source code is, and almost like the Docker file which you're using to generate the environment that it's running in. And so everyone gets this and they can analyze it, and they all agree, yes, this is something we're happy to run with. And if you were to hash that program, it essentially creates different hashes of what exactly, all that source code and environment variables are. And so in the case of AWS, the hypervisor of the server, so not one of the parties, but actually the infrastructure itself, creates these digital signatures. So if you have the source code and all the environment variables, and you receive, you can generate what these hashes should be yourself independently, and you receive this attestation document, then you know that the cloud provider or the chip manufacturer is guaranteeing that that's exactly what's running inside of the enclave. No one can SSH in there. There's no IT support person who might be able to see what's running through a command line interface or something. Very much what you see is what you get, and it's a very isolated input and output. Very isolated in terms of its inputs and outputs. I'm not sure if that helps though.
Thanks. Matthias, you wanted to add to that, or?
Yeah, no, I think they are quite fascinating use cases, because like this use case is about using proxy non-sensitive data, of course, to see whether we can have collaboration across borders on statistics. And then we have another use case which is kind of which is the Canadian use case, where the homomorphic encryption, which is the data are encrypted at all time, is used actually to protect the data provider who doesn't trust the cloud provider, but this is being done in a cloud. So the data is at all time encrypted, and actually the cloud provider that is running this infrastructure can't actually see any data, and only results then go to the output party. So there is really a lot of very different use cases. So it's sometimes very difficult to navigate. So that's why we are trying to also help with this experimentation, but also with the handbooks.
Thank you. Thank you very much for that. We've gone a little bit over time. I want to thank our presenters. So Dimitri Ruta, Tanya Flower, Esperanza, Mike Pante, Sam Esco, Matthias, and Jack Fitzsimmons, Maciek Juk and Jack Fitzsimmons for their participation here. I don't know if Dr. Ruta was still here, but I think he might have dropped off. Anyway, I'll thank everyone for your very informative presentation. What What it shows is that we've come a long way in which we are working with big data and data science in our community of official statistics. We've developed methodologies, and as you've seen today, there are also quite a few advanced applications already running and available. We like to interact with academia, private sector, and others on these topics, and the invitations with which all of these task teams have put out. They're on the table, and we hope that people pick up on that and get in touch with the various task teams and the various presenters. So with that, we close the session today. Thank you very much. We have a next session in 2 weeks where we will discuss in more detail the training, because methodology and everything is very advanced, and what statistical officers need is to get the skills and competencies that are needed to be actually use these new methods. So with that, thank you very much, and I hope to see you back in 2 weeks. Thank you.